Hello friends, today's question: water from a tap emerges vertically downwards with the initial speed of 1 meter per second. The cross-sectional area of the tap is 10 to the minus 4 meter square. Assume that the pressure is constant throughout the stream of water and that the flow is steady. The cross-sectional area of the stream 0.15 meter below the tap is. So we are given that there is a tap, let us suppose something like this, and water is flowing through it, and we are supposed to find out the area of cross section of the stream at this point, which is 0.15 meter below the tap. Okay, so this question can be solved by using two approaches. One is by the use of Bernoulli's principle, and the second one is using the kinematics equation. So let us first of all use the Bernoulli's principle. So Bernoulli's principle states that Bernoulli's equation rather. So pressure energy plus kinetic energy plus potential energy is constant. So we have, let us suppose we call this as 0.1 and this as 0.2. So it means the potential energy plus kinetic energy, pressure energy at 0.1 will be equal to potential energy plus kinetic energy plus pressure energy at 0.2, and then we are going to solve it in order to find the solution. We are going to use two approaches. First is by using Bernoulli's equation. First method, which is Bernoulli's equation. And it states that for incompressible and steady flow of liquid, for incompressible and steady flow of liquid, pressure energy plus kinetic energy plus potential energy will be constant. So we have considered 2 points, 0.1 and 0.2. So if we say the pressure energy at 0.1 is P1, and you can say velocity at 0.1 is V1, H1 is the height of point P1, and similarly pressure at point P2 is pressure at point 2 is P2, velocity is V2, and height is S2. Therefore, we can write the equation as P1 plus half rho V1 square plus rho G H1 is equal to P2 plus half rho V2 square plus rho G S2. So our P1 and P2 are pressure at 2 points, pressure at 2 points, V1, V2 is velocity at 2 points, and H1 is H2, height of two points, and rho is the density of the liquid, and g is the acceleration due to gravity. G is acceleration due to gravity. And in the question itself, it says that pressure is constant throughout the stream of water. So we can say that pressure at both points is same, which means P1 is equal to P2. So therefore we can cancel P1 and P2. So we get, let me write this equation once again, P1 plus half rho V1 square plus rho g H1 is equal to P2 plus half rho V2 square plus rho g H2. So P1, P2 cancels out, and now we are left with the equation as half rho V1 square plus rho H1 half rho V2 square plus rho g H2, and rho also cancels out throughout, and in this case we assume that the height, or we can say the point 1 is our reference point. If point 1 is a reference point, then we can say that the value of H1 is equal to 0. So we will consider point 1 as a reference point, which means H1 is equal to 0. So this is suppose point 1, and point 1 is taken as a reference, and we have a point 2 somewhere here. So point 2 is below the reference point, therefore we can say our H2 is equal to minus of H. So point 1 as a reference point, therefore H1 is equal to 0, and point 2 is below the reference point, therefore S2 is equal to minus of H. So substitute in the equation, in this equation H1 is 0, so we are left with half V1 square plus 0 is equal to half V2 square and minus H, GH. So we can further modify this equation, and it can be written as V2 square is equal to V1 square, and we get this as plus, this will be our 2GH, and V1 is already given to us. V1 is given as 0.1 whole square plus 2 is 9.8, and height is of the 0.2 below is given as 0.15. So we can say that our V2 square will be coming as 3.94. So approximately we can say V2 is equal to 1.985 meter per second. So we found out the velocity at point 2. Now we are going to use equation for continuity to find out what will be the area of cross section. Using equation of continuity, we states that A1 V1 is equal to A2 V2. So we assume that area at point 1 is A1 and area at point 2 is A2. So we already know our, you can say, area of cross section of the tap is given as 10 to the power minus 4. So A1 is known, V1 is also known, V2 we just calculated. So from here we can write that our A2 will be equal to A1 V1 divided by V2. Substituting the values, we get A2, A1 is our 10 to the power minus 4, V1 is our 1.0, V2 1.985. So this A2 comes approximately as 5.04 into 10 to the power minus 5 meter per second. So this is the area of cross section of the stream below the tap, which is at a distance of 0.15 meters. So this we used, you can say, Bernoulli's theorem, and we can use equation of our kinematics also. So you can say, let us suppose this is our second method. Equation of kinematics, which states that velocity at point 2 whole square is equal to v1 square plus 2gh. Okay. Once again we substitute the value. This is 0.1 whole square plus 2 into 9.8, and height is given as 0.15. So once again we are going to get same answer. V2 will be equal to 1.985 meter per second. And now using the equation of continuity, equation of continuity, A1 V1 is equal to A2 V2. So from here we get A2 is equal to 10 to the power minus 4 into 1.0, 1.985, and which comes approximately as 5.04 into 10 to the power minus 5 meter per second. So the option available to us, you can see that option number C is the correct answer. Option C is correct. So in this we can also see that the equation for kinematics and the final equation which we got by using the Bernoulli's equation is same. Okay. So this completes the question. Thank you. Sorry, the area is meter square. My mistake. Meter square, and here also area is meter square. Thank you.